Now we're gonna burn some things with a Bunsen burner, and we're gonna see if there's a physical change or a chemical change. This is a piece of magnesium metal, and I'm gonna directly light it in a flame. And so what we are observing is very bright white light, white smoke. And when it's done, there's this powdery ash left over. Definitely something new was made. Later on, we'll learn that that's magnesium oxide, the magnesium combined with the oxygen in the air. Then we're going to take a small piece of wood, and we know what this one's going to do, but we're just doing it to prove a point. You light it. There's light coming out of it. Light generation's a sign of a chemical change. Plus, give it a little while. And when we're done, there's this black ash that's left over. That's mainly carbon. So again, that's a sign that something chemical happened. Here's a piece of steel wool. It's a very fine ground up piece of steel, iron. You see that it burns very bright. And again, it's this black ash that's left over. It does not have the same appearance as before. It's oxidizing, so that's a chemical change right there. All right, and then the last thing I'm going to heat directly is a newer penny. New pennies are not made of copper. They're coated in copper. This one's going to take a little bit longer, but we're going to stay with it till it changes. The hot part of the flame, by the way, is near the very top of it where there's more oxygen. I can't tell if you can tell, but I can tell that it's starting to look kind of shiny, silvery looking, because some of the copper's being vaporized away. And we're going to keep waiting until it changes. It's close. It's trying. You can see it's kind of like bulging at the bottom. You see it at the bottom? And the inside of the penny is made out of zinc, which has got a really low melting point. And patience. Let's see if I tap it, if it'll take care of it. Ah, there we go. So all that right there is the zinc that's on the inside. All it did was melt. It's still copper and it's still zinc. So that's a type of change. Is that physical or chemical? You think about it. All right, the rest of these objects we're just going to burn indirectly, which means we're going to put them up here and we're going to burn them from underneath. The first thing we want to do is a wax crayon. Okay, and she will look at this from the top. Your guess is the crayon's you probably know what it's going to do. It's starting to melt. So once you decide what kind of change is melting, you can write that down. I want to go just a little further though. You see the crayon is forming right there. And notice it's starting to smoke. Anytime you start to smoke like that, you're starting to chemically break down. If I continue heating this crayon like I'm doing, I'm basically cooking it. And it's not what it was before. So if I continue, it'll darken and burn. All right, so melting is one thing. See all that smoke? It lets you know that something more than just a physical change happened. All right, and that will reharden back in a minute. All right, we're gonna do a piece of sugar. This is a pretty big cube. Hopefully it won't take too long. And nothing yet. Nothing yet. We have to be very patient. Nothing yet. You may not can tell from the bottom, but the bottom looks like it's starting to melt. Starting to turn brown. And if you ever eaten caramel candy, that's what it is. It's just melted sugar like syrup. It's just melted together. As long as you don't do it too long, it's really good tasting. When you go too far, that's when it's a problem. So this thing is starting to cook and to caramelize. You can see it right there. Because it's not the same thing it was before, it's a certain kind of change. You see the caramel cooking. If we keep going, this will actually burn like you could burn sugar in a pot. And now you see the black forming, that's carbon. That's far enough for us to make a determination as to what that is. Plus now you see all that smoke. All right, next thing we're gonna do is a piece of copper sulfate. Copper sulfate is a blue crystal. We're gonna heat it for a little while. Let's see if I can get the burner to agree to stay upside down. Yeah, I'm gonna burn this one directly. You see the green coloring? Copper burns green. That's a unique feature of copper. So when you burn anything that's made out of copper, you should see that green color. Notice what's happening to the blue crystal. It's starting to turn like into a white ash because what you're doing is driving away water. And so it's gonna turn white. Miss Hallie's gonna drop some water back on it and rehydrate it, and notice that it turns blue again. And you can go back and forth with this. So not only is this a color change is an indication that something chemical happened. All right, we're gonna do some lead. These are some lead pellets. Lead is a metal. It has a relatively low melting point, so let's give it a minute and see if we can get it to melt. And we only have one more thing after this. Not yet. Not yet. It's close there. It's starting there in the middle. Yeah, I can see it from where I'm at. Oh yeah, there you go. Notice how we melted it all into one piece right there. Okay, all it did is melt. It's still lead. So that should be an indicator of what kind of change. It's still lead. That would not feel good if it got on you. And the last thing we're gonna do, oh, sorry, we have two more. We have some sulfur here. Notice sulfur is this yellow powder. It usually comes in the form of crystals, but it's been crushed. Immediately it's starting to melt. It's got a really low melting point. You see it's starting to turn into this pretty yellow color and then brown. And completely melted. It had a really, now you start seeing black, so it's making something different. It's catching on fire. Do you notice it's on fire itself? Oh, definitely a chemical change. It's flammable. And if you let this go to completion, and if you were lucky enough to be in the room, you might have smelled the rotten egg smell that's typical of sulfur dioxide and sulfur trioxide. I just got it. All right, the last one is a kernel of corn, and that one's got a lot of fumes. Let's see what happens here. So it looks like a piece of dried corn. And nothing yet. I was gonna see if, lovely. Let's just do it right there. Speed this thing up. It's starting to burn. Oh, wait, I thought for a minute it was gonna pop. All right, it's definitely catching on fire, so it's definitely a chemical change. We were not lucky enough. Some of my classes actually made a piece of popcorn, which is great. Okay, there we go. What you wanna do is slow down the film, stop at each place and decide, write down the empirical evidence that you see and decide if it's chemical versus physical. Okay, thanks.